everybody. I think that's they closed the doors on us, so I think that's the sign to start. You've chosen to talk wisely. Thank you for coming, and good afternoon. My name is Thomas. I'm here to talk you through a few of the failure modes of data teams and how all of that works, and most importantly, how you can avoid it, because like it or not, 85% of data projects fail. These numbers are a few years old, but they're sourced from VentureBeat, so I'm sure they're true. A variety of reasons why data projects can fail. We'll go through a few of them. Let's make sure that after this we're in the 15% that succeeds. All right, just quick intro for myself, and then we can go into the meat of these things. I'm Dutch. I'm from the Netherlands, but I lived my life in various different countries. I grew up in Belgium. Studied theoretical physics in Leuven, moved to London in 2013 when data was just starting out, and then moved to Amsterdam a few years ago to then sort of continue my activities there. So I've had the privilege of doing data in all three countries and all three locations, which was very nice. And now today here in Malmö. I run a company called Tasman. We are 23 people. We work with startups and scale-ups to scale and bootstrap their data capabilities. What it means is we support them to build infrastructure, data warehouses, pipelines, and so on and so on, but also do the first batches of real insight, real dashboards, real deep insight, and so on and so on. And we also help them hire an internal team. So that's where this experience comes from. This is going to be really annoying, I think, if I keep... I know. I don't know how to switch. I think... Can I switch off the pointer itself? Let's see. Yes, I can. Oh, there we go. And yeah, and now here we go again. We all learn. All right, excellent. So that's what we do at Tasman. We support startups and scale-ups. This talk will therefore be about what startups and scale-ups can learn from data, how they can be better at data, and so on and so on. This is us in front of some crumbling ruins in Rome. What that has to do with the modern data stack, I'll leave as an exercise for the reader to figure out later. For whom is this talk? So just to get a feel of you guys in the room, who here calls themselves a data practitioner? Raise your hands. All right, cool. Who here will be more of a standard software engineer? All right. Who here is more in a management role, management position? Okay. Of the data practitioners, who is more on the data engineering side? Raise your hand. All right. And on the data analysis side? Okay, great, fantastic. So that's what we call a mixed audience, which means that you will hopefully all have something to learn here today. At Tasman, and I think in a sort of wider startup, scale-up data ecosystem, there's sort of three big role definitions these days. There's data engineering, which in the context of this talk, we're going to talk about data engineering as pipelines, making sure that data goes from place A to place B. Analytics engineering is making sure that the data is modeled and transformed and usable for analysis. And then the data analysis is responsible for making sure that there's a business relevant insight there. So this talk is for all of these three roles, for data managers, but I think engineering managers and engineers, actually I think there's a bunch of stuff here as well that might be interesting for you. So let's go. 3 pieces of context that I want you to have in your head and kind of remember during this talk. These are the sort of boundaries of the problem of data these days. First is that startup analytics tools have matured quite considerably last couple of years. I don't know who here was, who here was practicing data 10 years ago? Raise your hands. Steph did, I know that. All right, okay, great. The tools have matured significantly. Let's keep that as a sort of dogma here. Second, starting and scaling data teams, however, is still really difficult, and in a way I think it's even more difficult than it ever used to be. I'll get into why in a second. And 3, there's many different ways to run your data team, and maybe the fact that the technology is so easy to get makes it harder to run data teams in particular ways. So, over the last 6 years at Tasman, we're doing this for about 60 clients. What did we do? We made mistakes. A lot of mistakes, and we're going to share these mistakes with you now, so you don't have to make them yourself. So it's a bit of giving back to the community. The 3 takeaways that I want you to take with you at the end of this talk. One is, in order to avoid making these mistakes, one is prioritize the way you choose your stack in a startup, scale-up, any dynamic business environment, based on what you actually want to do with it, not based on what the most technologically sound choices are always. There's exceptions, but prioritize it based on business outcomes. Second, when you build a data model, model the business rather than the data and do it in what we call a domain model. Those of you who have been to Bill Illman's session this morning will know that he has a particular way of thinking about it as well. We'll go through that as well. And then takeaway 3 is actionable insight. It's always the goal. Produce valuable insight to the business, but make sure it's actionable as well. So we'll talk through precisely what that means. We'll come back to the slide at the very end just to make sure that I haven't forgotten any of this here. Taking a step back, right, modern companies, startups, scale-ups, any companies that are quite dynamic, they're expected these days to be very good at data, but somehow they fall short. And there's 3 reasons for that. One is that complexity of the landscape is increasing. It's a complex landscape. There's a lot of tools. What is your best data stack for scale is a big question that people ask. Secondly, rapid growth, right, means that your requirements are not the same now as they will be 6 months from now. If you're in a fantastically growing startup and you raise a Series A, you get a whole bunch of new stakeholders in, and so your requirements 6 months from now will be very different from what your requirements are today. So how do you build and design a data team? How do you build and design a data model that accommodates for that and takes care of that? And then 3 is, it's very easy. I say that as a consultancy, but it's very easy to spend a lot on data. It's very hard to get that spend to actually return on investment and be actionable. So what's the most efficient way you can create that actionable insight? That's the intro. So let's now go into the meat of this and start with pitfall number 1, mistake number 1, which is reinventing the wheel in the data stack. Data collection is better and is cheaper, more efficient than ever before, collection, storage, transformation. And at the same time, in the landscape, you've got a lot more modular open core tools that are very high quality, right? But that introduces complexity because it means that you have to choose. And when you want to centralize your data, so imagine you're starting out as a data engineer, analytics engineer in a startup or in a new team, and there is data that needs to be centralized. How do you go about that? How do you go about it in terms of tool choice? How do you go about it in terms of methodology choice? Well, I have no idea what the resolution of this. The point is not the text itself. The point is that this is the analytics landscape as Andreessen Horowitz visualized it last year. This is a complex landscape these days, right? I'm sure that you recognize a bunch of these graphs and names on here. This is not simple whatsoever. And even when you reduce it to relatively pure BI capabilities, even there, it's still a very sort of, how shall I say, convoluted set of choices you have to make. So imagine yourself having worked within, say, a well-set-up data infrastructure. You join a startup and you have to sort of navigate this straight away in order to set up your tooling. This is not simple. Many teams fail here already because they don't make the right choices, or they skip over parts of this end-to-end value chain. What we do, or at least what we will recommend and how we avoid making these sort of decisions, is we take a bit of a step back and we think about what you actually try to realize with that data stack. And what you realize is centralizing your data, making sure that you've got one single source of truth that all of your data lives in. And that means that your data warehouse, I'm going to try and not hit this pointer device again. That means that your data warehouse that sits at the core of this is indeed the heart of the pipeline. That's where the magic happens. You want to make sure that when you gather your data from the sources, you ingest it at an as raw as possible level. You model it properly, and then you make sure that you can consume it within a single source of truth over there. That's the philosophy of centralizing the stack. That's the philosophy of centralizing your data. And when you do that, and in our case, I'm just going to take you through what we see as a sort of very standard stack setup that works well with this. That is a good sort of initial setup here for your data ingestion and transport. Tools like RudderStack for event analytics, Fivetran or Stitch for more classic ETL or ELT, connecting to third-party data. Tools like Avo for event governance, making sure that you got all your ducks in a row when it comes to event definitions. Snowflake, whether it's BigQuery, whether it's Redshift, doesn't really matter too much, but if we have to build a stack from scratch, it will be Snowflake. Transformation, dbt, I think it's, let's see in a few years, but I think at the moment dbt is ubiquitous as a data modeling tool. Just out of interest, who here has worked with dbt? Okay, interesting. So we'll go through that a little bit as well. And then in terms of analysis and output, the sort of different ways we're going through that are tools like Metabase, if you want to sort of quick and dirty solution, Holistics, if you want more self-service or more more centralized modeling, Hex or Count for notebooks, or just even Python or R notebooks if you want to do some deep analysis. If you build a stack that looks like this, you're on the right track. It sort of satisfies the requirements of keeping it simple, centralizing your data, going from there. So that's tool choice. But if I build this graph a year from now, it will probably be different. So that's how fast the industry is moving. Elementary, that's data activation, but let's not talk about it. So that's observability, and high touch is data activation, but let's not talk about that right now. When you set up your stack and you're happy with your Snowflake instance, your Rudder stack, your pipelines, and so on and so on, choosing the tools is not sufficient. You need to also ingest the data and start modeling it, cleaning it, modeling it, and so on and so on and so on and so on. And if you just started as the first data hire in a startup, just looking at that hypothetical scenario, the first question you're going to get is, where do you start? Right? So imagine just a hypothetical startup, very typical mobile subscription startup, for instance, that acquires customers via Facebook, that has tracked and is tracking a bunch of app events in their mobile apps, that has ReviewCat because they run subscriptions, mobile subscriptions. ReviewCat is a very good tool for mobile subscriptions. It's part of that new wave of analytics tools that has come in. That is looking at tools like AppsFlyer or Adjust for making sure they know where their installs are coming from, and that is running some A/B testing. This is very typical mobile subscription startup. Even a e-commerce startup replaced subscription reporting by Shopify or something like that. That's why we see a lot of companies that are just about to raise an A series or that are just beyond the A series stage. So relatively typical startup setup. If you're the first data hire and you come in and you're supposed to centralize all of this, the worst thing you can do is spend 6 months building all the nice infrastructure that grabs all the data, puts it nicely in the data warehouse, and only then worry about what you're actually going to do with it. Because if you're working in a startup, 6 months is an eternity. It's the difference between life and death for a startup. So somehow, in those first 2 months of your employment at this new startup, you're going to have to deliver some business value. And prioritizing your data sources is important there. Some of the example reporting, for instance, that you can then look at, again, the typical startup scenario are things like campaign performance modeling, code reporting, revenue reporting, A/B test analysis, driver analysis, deep insight, and so on and so on. Rather than trying to cover all of these, the key, of course, is to go to the business and start prioritizing it. And then you might get a prioritization order back that says, actually, we don't have any revenue reporting at the moment. Let's start with revenue reporting, which is great because revenue reporting only needs one of these data sources. So there's your prioritization answer. Look, this all seems very straightforward, but it is very common particularly in data teams, and particularly with the direction that they're given by CTOs or technical stakeholders within the business, to be given just a technical brief around, hey, come in and centralize our data. What I'm saying here is that is quite a big risk to run in a data team. We see a lot of data teams fail because of that, because they don't manage to, in time, create the business value that is their reason for existing. And so therefore, having this sort of prioritization framework is the key to success there. Every single sort of project that we come into, at the very least, that we see friends and network community acquaintances come into, starting with revenue because it's the existential thing for a startup, is always the thing to do straight away. I'm just going to skip over this for a second. Thirdly, when we've set up the stack, we've centralized the data, you know how you're going to make sure that whatever data you're centralizing is actually relevant for the business straight away. How do you then make sure that it's clean and trustworthy as well? Because it makes no sense to build this incredibly sophisticated analytics stack on top of shaky foundations. And so there, very typical scenario as well, that a startup data team has put all of this effort in building the best possible data model, the best possible data stack, but no one trusts the numbers because the data team has not really understood the initial assumptions for the data sources that you're looking at here. So for this hypothetical startup example, with these 5 data categories, how do you go about trying to understand them? Well, for Facebook ads and for ReviewCat data, for Facebook data and attribution data, it's aggregated, it's already interpreted for you. You just need to understand the schemas and the available pivots. For instance, Facebook ads allow you to get data out in a creative level, which means all the way down to the ad level, with number of impressions spent to it and so on and so on. But they also allow you to split it by country or by age group and so on and so on. But it depends completely on the way that you set this up. And the way you set this up has massive repercussions for your data model down the line. So be very aware of how these sources are set up and how you extract data from it. Attribution information is also quite tricky, making sure that you know how the attribution data is gathered and what the assumptions and requirements are. Very simple example, attribution information with app tracking prevention in modern day iOS, you're only going to get attribution information for about 20 or 30% of your user base, if you're lucky. Knowing that as a sort of upfront assumption, again, it doesn't sound that complex, but there's so many of these different assumptions with all of your data generating systems. Being deeply aware of them is the biggest insurance I can recommend in building data teams and scaling your data teams. Right, so that's the simple stuff. More complex, revenue cat and subscription reporting. Again, App Store limitations. There's a huge amount of edge cases here, which in data, because most data teams, particularly in startups and scale-ups, they don't have clear interfaces, so to speak, with the engineering team or clear documentation from the engineering team often as well. Going out there and trying to understand what the assumptions and edge cases are around your subscription data is really important, because things like grace periods of 5 days might really mess up your subscription transactional modeling or your churn modeling and so on down the line. A/B test, A/B test data, I don't know who here has worked with A/B test data, but it gets really messy really quickly, to the extent even that we recommend most small companies to stay away from A/B tests until the moment that they've actually managed to set up a proper mature data stack. You can, of course, use a tool like Optimizely and just use their UI, but within the data warehouse, it is a very complex modeling exercise. Not helped by the fact that most startups that we know do A/B testing kind of get very excited and all of a sudden start running 15, 16 tests in parallel. And those of you with statistics backgrounds know that the significance of your numbers decreases quite rapidly as a power of the number of tests you run in parallel. Anyway, that's a lot of scar tissue that's buried underneath that graph over there. App events, worth pausing on that for a second. So, who here is working with event data from time to time? Okay, great, fantastic. So, you know, event data is great because you control it, right? As in, you're able to precisely define the type of event you want to build. You're able to look at it as objective data because you're tracking something that's like a conversion event or an installation event or a gameplay event or something like that. That's all great, and we love event data because of that. The closer to the source you are, the better. It's much better than the aggregated information like from Facebook and from Revenue Cat, because you know exactly how the events are being generated. But beware, you need a tracking plan. And why do you need a tracking plan? Why do you need governance? Well, 3 reasons. First of all, you need to make sure that if you have, say, a conversion event, and you've got 3 platforms, you've got iOS app, you've got an Android app, and you've got a website, that event is being tracked in the exact same way across those 3 different platforms. Sounds simple, trust me, it's hard, right, to get there. Maybe conversion events are simple, maybe sessions are different, maybe page views are different, right? Make sure that you have consensus and consistency in your event definitions. Versioning, you might be able to track your entire app setup right now, but your features will change. If you're a startup, your app will look different 6 to 12 months from now. Making sure you have an inbuilt way of tracking the versions of your event and what type of the app or what version of the app they relate to is critical. That's the way you're going to scale, and that's the way you're going to make sure that a year from now, 2 years from now, you can still refer back to the November 2023 data and make sure that you know what it is all about. And the third component is just a forcing function of designing your tracking plan, designing your events. It's very easy to go and track everything, particularly startups or scale-ups that are ready to hire a data team. Typically, they've got some event tracking these days in place already, but it's built by the engineering team, which is not a problem. That's fantastic, but typically it's built as if it's another sort of logging. Typically it's built as in, hey, we're already integrating with Firebase. Let's just send everything that we send to Firebase into BigQuery straight away as well. That means that there's not really any design, there's not really any sort of considerations around using the events for analytics first. So make sure that you have a clear idea of what you're going to use the events for, and then build a tracking plan that again prioritizes the events you're going to need for your first business use case straight away. We do that in tiers. Tier 1 data is business critical, things like conversions or installs or registrations. Tier 2 is everything that backs that up, like gameplays or browsing behavior on a website. And tier 3 is everything around UX flow. And typically we just forget about tier 3 and just implement tier 1 and tier 2. But going through that exercise is quite useful up front. There's tools to help you with that. There's a tool called Avo. Go to Steph's talk tomorrow morning if you want to learn a bit more about Avo and so on and so on. But essentially, it allows you to have a nice little governance tool that allows you to collaborate with your engineering team and with your other analysts in not just knowing what the definition is of everything. I apologize for the resolution, but also in, for instance, knowing exactly what UX touchpoint an event is being fired. So getting that as documentation in there, it's a nice tool for that. It also does inspections and code generation and snippet deployments as well. We love it. All right. Closing off the sort of infrastructure chapter, do your business analysis, know what you're going to use it for, build your data stack, centralize your data, define your events accordingly. All right. Pitfall 2, data model chaos. If you've managed to successfully set up your data infrastructure, you're centralizing your data, if you've got your tracking plans in place, the next pitfall that a lot of teams fall into is not really thinking about the data model or thinking only about the data model as a sort of afterthought. And typically in the form of, I got 2 reports with 2 different numbers. Why is that the case? Why is that important? The analysis tools, they need to consume from a shared single source of truth, otherwise you're going to get discrepancies. In startups, that's typically solvable by just 2 stakeholders talking to each other and agreeing what report they use, right? But as you grow, you need to make absolutely sure that you deliver quality data. It's very hard to build trust in data, it's very easy to lose it, and 2 reports with a different lifetime value number is the surest way to lose the trust straight away. Secondly, subjective, but I think data modeling is a bit of a lost art. I think the fact that data storage is so cheap these days means that people just push back the moment at which you start modeling the data and do it as an afterthought later down the line rather than as a design constraint in the system. And I'm here to help change that. I'm actually going into the data modeling itself in a much more technical talk tomorrow morning. If you want to know more about that, please join that talk at 9:30, I believe. But for now, just a very quick introduction. How do you build a data model that doesn't just serve the single source of truth, but also scales with the business? What does scaling with the business mean? It means that you're now 4 or 5 months into your job as the first data hire in a startup, and you've managed to centralize your data. You've got a nice Snowflake instance. The data is nicely structured. Things are working out well. You're happy. You've built a little data model around a few of the business questions you're going to get, or you're getting from your stakeholders, because again, you're building your data platform according to the needs of the business at that point in time. And you've built it on top of the 3 data sources you've prioritized. Now a new product officer joins, or a new product manager, and they're going to have a set of different questions. Maybe these questions are about data that you haven't really looked at before. So what happens is that these new business questions and this new data source makes you extend the data model. Once, that's fine, probably. Twice, 3 times, 4 times, it becomes really messy, really quickly. And the sort of the language that people use for this is query-driven development. It is scar tissue for myself as well. I very much suffered from this when I started out in data, not really designing the models up front. It is probably the biggest risk for you in a small, growing, scaling data team. So be careful for this. How do you avoid query-driven development? This is, by the way, an example of what your DBT DAG, so your data model map, looks like after a few years of query-driven development. I should say, by the way, that this is actually DBT's official kind of internal data model. This is not what a nice data model should look like. I'm being very opinionated, but this is very messy. Each of these little fields here is a table, and there's no structure or separation of concerns in the models here whatsoever. So how do you avoid that? How do you avoid having to extend your data model every time you get a new question? How do you avoid having to extend your data model every time you have a new data source, or every time that your sales team swaps out Pipedrive for HubSpot or swaps out HubSpot for Salesforce? And the key thing here is to realize that there's such a thing as a static target. And as I'll go through tomorrow morning as well, it's great to be in data because there's a lot of problems to solve, and we can actually look at engineering, software engineering in the 1980s and 1990s and just borrow a lot of the concepts developed there. So I'm going to talk about static targets and separation of concerns here as the sort of main philosophy for data modeling. the business is a static target. Once you've achieved product market fit, if you're that mobile subscription game, well, the business itself is not really going to change that much over the next couple of years. It's still going to have games, still going to have a subscription model behind it, still going to acquire users via marketing campaigns, and you're going to find a level of abstraction that will describe the business as it grows. All right, you agree with that, I'm sure. That means that all of these business questions, right, they will all feed off the static target of the business as a sort of static target itself, right? So that means that if you can describe the business as a static target, then all of the business questions are answerable by the information about the static target you have. And the data model should reflect that. It should reflect the ability to answer every possible business question, right? Because you can maybe build the data model as a static target as well, describing the business. So rather than build your data model based on your available data sources, build your data model describing the business instead. That's what we mean when we talk about domain modeling. It is what in sort of abstract thinking is called entity modeling. I think a lot of you as engineers will have done a bunch of entity modeling, of course, in the past. It used to be very popular. In data, we call it domain modeling because it describes a domain. It means that your central layer of your data warehouse, rather than be a bunch of fact and dimension tables, it is actually tables that describe a user object. It's a table that describes a transaction object. It's a table that describes a subscription object. In a centralized stack, that sort of static layer sits in the middle. You feed it with a source and staging layer that allows you to make sure that you clean the data, you deduplicate it ahead of time, and so on and so on. And you query it with a set of data marts in your presentation layer that just allow you to do a little bit of joining where necessary. But that domain layer, not just does it allow you, it doesn't just allow you to describe the business as a static target. It also, because it doesn't change as your business requirements change, it allows you to, for instance, swap out Salesforce for HubSpot or vice versa and not change your downstream dependencies. Because all you need to do when swapping out HubSpot for Salesforce or vice versa is change the way that you load the data into the domain model and go from there. Building this from start is not that hard. It's almost a paper exercise, but building this layer of abstraction in your data warehouse is a key enabler for scale in your data team. It serves as this sort of single source of truth straight away. This is what it looks like in reality. Again, I apologize for the lack of resolution here, but it is a nice little paper, logical exercise to try and understand how your business actually works. Every single question you can ask about the business will be answerable with a combination of the entities and the objects that are on here and the relationships between them. For instance, a conversion event exists only within the context of conversion stage and with the context of an engagement event of a user clicking on the actual button that converts them. That's the level of thinking that you're thinking about here. A user object interacts with a subscription object. A subscription object interacts with a set of transaction objects in a one-to-many relationship, and so on and so on. Very much worth exploring this further if you haven't done that. Benefits are static target, scalability. As the business scales, your data model stays static as well. And under-illuminated, doing this in the data team is actually a form of internal consultancy and business analysis you're doing. Because it sounds very technical, but when you build this, you're actually going to start talking to your marketing team and have a very good idea of how they acquire users. What is a creative object? What is a campaign object? How do you define a campaign? How often do you define new campaigns, and so on and so on? And because not only are you defining the objects, you're also defining the definitions of those objects, it means that you get consensus about the business logic. The amount of times, even in startups, where we have to sit down and try to make marketing, sales, product, and finance agree on the definition of a user, it's difficult. This domain model exercise allows you to do that upfront before you write one single line of SQL. All right, when you then translate that into what the stack looks like, is this readable at all, by the way, from there? Ish, okay. So translating this into stack means that you got your ingestion, you get your data warehouse with your different layers and your separation of concerns in there, and that's your single source of truth that comes from there. Translated in the methodology, your warehouse essentially ends over here, and then a set of data marts per data function take over. But again, more about that tomorrow. All right. So tip 2 is, if you want a scalable data model, model the business rather than model the data itself. And fill out the business model with the available data as a static target. Pitfall 3, sad stakeholders. Right? So centralize your data. You have the best possible data stack. It's really nice. Everything is humming along perfectly fine. It has 100% uptime and so on and so on. You build a brilliant data model that allows you to build fantastic dashboards on the back of it and fantastic deep insight. But no one is really using it, or you find yourself in a position where there's about 1,000 requests for different dashboards and reporting that need to be filled out. How do you make sure that your stakeholders are actually using the data, making sure that it's actionable? So first of all, the topic of self-serve has had a lot of attention over the last couple of years. It means that stakeholders, business people are able to build their own dashboards and serve themselves, build their own insight. It has come under a lot of fire as well, because I think there's people arguing quite convincingly both that self-serve is the only answer, or that self-serve is impossible because business stakeholders will never really understand the data. And of course, I'm here with the nuanced answer to say that self-serve is possible, but it can go wrong very easily. So this is an example of how self-serve goes wrong. This is a typical Looker Explorer. It's actually from the Looker demo environment. I think it describes an e-commerce setup. I think that was their demo environment a few years ago. It has a kind of model for orders. It has a model of items within the order. It has a model for the users that make those orders. But it has a bunch of problems straight away. So first of all, it has 153 fields in this Explorer, right? 153 fields is too many fields. Even if you define and describe and document all of them, there's no single business stakeholder that can really understand all of them. Secondly, out of those 153 fields, you got about 11 or 10 date fields in there. That's too many date fields, people. Again, this is a demo Explorer that is as cleaned up as possible. 10 date fields means that, sure, you might have a few nice, happy stakeholders, but in a week, your chief product officer is going to want to try and understand how much they sold last week, use the wrong date field, and get a massive Looker error because the aggregation doesn't work anymore. And then what happens at that point is there's no understanding of, oh, we understand semantic aggregation doesn't really work in Looker. No, there is why do the dashboards not work? Let's burn everything. Our data team is not paying off. That's the pitfall. So how do you combat that? How do you make sure that that doesn't happen? What we do is, in Looker itself, and we use a few different tools these days. We use holistics, but it's sort of similar. If you use simpler dashboards, it doesn't really have the same problem. But let's just talk about Looker and holistics type models as an example here. We build very curated environments for business users to build their dashboards in. And that means that, first of all, they're very well documented. So this is one for a company called On Deck, which is a fellowship incubator. Accelerator in the US. It only has 44 fields. I'll just read out the number so you can so you know what it is. And it has a very clear set of objects that is well documented in the internal data dictionary as well. But only 44 fields, and we try to only have one, max 2 date fields in there. So that there's a very clear set of dimensions and measures you're supposed to use. And then what we do is, rather than serve it as a sort of empty Explorer to users or empty environment, we try and preempt 10, 15 different business questions, build a little graph that answers those business questions, and then serve those in a little Notion page or document to your business stakeholders. Because that way they can just pick the graph they want, say, okay, this looks great, but I actually want the country as a pivot in here, drag the country in there as a pivot, and there they go. Make it very easy. You need to pre-choose some of this a little bit, but that's the way that self-serve can work, and that you can make sure that as a data team, you have the time to build your nice data models rather than build a lot of reporting all the time. Secondly, slightly mindful of time, how do you collaborate? How do you make sure that as a data team, you're always doing the piece with the highest business value and the lowest complexity? There's multiple ways. One way that works for us is to always, and whether we are an internal team or whether we do it as part of our standard activities, we make sure that we really deeply understand all the requirements of all the business stakeholders, and we have a roadmap on the back of that. We call it MAST, doesn't really matter too much. That roadmap has user-level deliverables, things like we need to build this admissions funnel to report on end-to-end traffic, or things like, hey, we actually need rotor stack tracking community as well. That could be user story as well. It has associated business value and time criticality. This is not done on a sort of ad hoc day-by-day basis. This is done every couple of months as a sort of exercise to make sure that you know what you're doing. We're consultants. We need to do that because we need to defend the spend on us. if you're an internal data team, please do something similar, right? Even if you're just the only person in the data team, please have an overarching roadmap of what you want to achieve, what the business value of those achievements is, and how you want to go about it. It helps you. It's the only thing that can help you against a ticketing-based system where the person with the loudest voice or the biggest job title gets priority in dashboard production or something along those lines, right? Because you can focus on one or two of these things at a time, but not all of them at the same time. That's a sure way to get into data model hell and to get into stagnant development. That's then translated for us, but I would very much recommend to do the same thing in your case into very deeply spec'd out tasks in Monday in this case that contain a lot of what we call business analysis. It means that every single task, every single subtask always have to tell us the context behind it of what epic in the roadmap is actually pushing forward and going from there. Having that in a central place also allows you to, at any point in time, say, this is what we delivered over the last couple of months, and this is what we're going to deliver over the next couple of months. And then a lot of you are engineers, almost all of you are engineers, so I don't need to tell you about the utility of proper peer review. We run everything through pull request, CI/CD, with a lot of testing in there, and proper peer review, because that's the way we share knowledge and information internally, making sure that that happens. This is one of the reasons we like Looker and Holistics, is because it allows us to build our entire analytics stack. So not just the data model code base, not just the infrastructure, but also the dashboards and the reporting. Everything is code. Everything is properly version controlled and peer reviewed whenever new contributions are being made. And you see that I did take out a rather nice example, but we try to document our peer reviews as well as our pull requests as well as possible as well. All right. Last point then, closing out on this. You've built your data stack, you centralize your data, you know the data model you're going to build, even if you've only populated maybe 30% of the fields. You know you're building out the static target. You are activating you're serving up brilliant business relevant insight to your stakeholders that can self-serve because you've designed the Looker explorers around them. How do you make sure that people are actually using it? How do you make sure that 3 months, 6 months, 12 months down the road, your dashboards are not forgotten somewhere in the drawer, but actually being used? There's 4 pillars there that we kind of always follow, that we find work well here. Because again, activation is the biggest killer of data projects after they're delivered. The amount of data projects that have built the best possible reporting toolkit, but then are not used. I think that's probably where that 85% of data projects fail comes in as well. How do you activate it? Not just that moment of handover, but everything around it as well. First of all, I'm afraid you're not going to avoid training. That's part of the self-service, but you also need to make sure that your business stakeholders know the limits of what you're building. What are they supposed to use this report for? What decisions does it help them make? And how do they go from there? Secondly, possibly most importantly, is feedback early. Iterate very quickly. Feedback early or fail is the sort of the motto that any team should follow, particularly in rapidly growing dynamic environments like startups. Make sure you get the feedback early. Make sure you know whether the dashboard is useful for your customers or not. Why is that important? Even if you sit down for 2 days with your product manager and you build a dashboard that's exactly to the spec that they've given you, chances are it's not going to do what they want because they don't have the context about the data that you do, and they don't know what's possible necessarily. So get that first version out very quickly and then iterate from there based on their feedback is critical. Third one is monitoring. And actually in Looker and equivalent tools, you can actually see whether dashboards are being used and by whom they're being used. There's a whole object model behind that. Do that because you're able to see that if you've got 500 dashboards, chances are only 10 of them are being used, and you kind of want to know which 10 those dashboards are so you can make sure to focus on them. Don't build 500 dashboards, by the way. It's also a problem. And then the fourth thing is, particularly if you're in a slightly bigger company, having a network of internal champions that, as a data team, you develop, you help activate, and you really support. That's really important. So typically the way that these things go within companies and the way you get to proper data-driven decision-making, although that's a fully different talk, is by having a few well-selected, well-trained champions within the teams. Someone within product who really likes data and really works with you well. Someone within finance, someone within the customer acquisition team, and so on and so on. Build up those relationships with those champions and stakeholders. And just as a fifth hidden point, I think heading of reporting is only the beginning. Make sure you keep talking to the business, and that's if you go away from this I've got sort of the summary of big tips, but actionable insight. And the takeaway from this component is talk to the business. Make sure you don't see your role as a data team to produce something and then throw it over the fence. Go and spend time with the business stakeholders, trying to make sure that they understand what it is that you build and iterate from there. All right. The 3 takeaways again. Make sure that when you build up your data stack and you centralize your data, that you do that based on the business outcomes that you have and the results that you expect from it. Secondly, when you start data modeling, make sure you design your models up front. Please design your models. Whatever philosophy you follow, please think about your models before you build them. And if you then build them, our preference is to build them in a static target architecture, rather than domain model architecture. And 3, don't forget that what you're building is actionable insight. Your data stack is worthless. As a data team, you are worthless if you're not producing insight that's used by the business to make better decisions. And that should be in mind all the time. And with that, thank you very much for your attendance. Woo. Let me put this up here. All right, any questions? Yes, Hugo. Yeah. Hmm. Yeah. Yeah. I wish I had better tips. It's not simple. So just repeat the question for those of you who didn't hear it. The 4th pain point is if your company is not ready for data-driven decision making, right? There's nothing you can really do in a team. How do you go about that? I think there. Look, if your company is not ready for data-driven decision making, chances are that it's not going to be a data team as a sort of first thing. I've not seen a company. I've seen a lot of companies that want to talk about data, but for the moment that they need to invest in it, they all understand the value of data in their decision-making cycle. That being said, if you do find yourself in that position where someone is making intuitive decisions, right, I think start small and be preemptive. So this is where it is incredibly important, certainly if you're an analyst, but actually also if you're a data engineer or an analytics engineer, to understand the business you're working for, understand the North Stars. Even if the company is not data-driven, they will have a North Star what they're trying to achieve. If you're a mobile subscription startup, for instance, either you're focused on acquiring new users or you're focused on retaining existing users. Those are 2 quite different North Stars. Not that many companies are focusing on those 2 things at the same time. And if they do, it's probably going wrong. Right? If your company is focusing on acquiring new users, well, as a data analyst, you can actually then start to suggest small reports that would make that easier. Again, if you work with business stakeholders, they typically don't know what the data you have is capable of. So they might need some hand-holding there, right? And you'll find that they're going to be much more receptive for that data-driven decision-making if you put the actual data in front of them and show them what it looks like and going from there. But yeah, so my thing would be there, if they don't necessarily meet you in the middle around, we want you to build dashboards to support our decision-making, and if you still find yourself in a position where you have the budget to build a data team and a data stack at the same time, then work on that North Star basis, work on the sort of, okay, what you actually try to achieve, and then go from there. Yeah. Yes. Yeah. Yes. Mm-hmm. Yeah. Mm-hmm. Yeah, you should see my code, but yeah, that's yeah. Do you need clean code standards? Yes. So just to repeat the question, in collaborating with other team members, particularly technical team members, how important is coding standards, clean code, and so on and so on? Because I think it's a good example that in analytics engineering, yeah, your code is almost necessarily clean because it's quite structured, there's good frameworks for it, and so on and so on. But in data science, if you're in any way like how I do data science or how I used to do data science, It is messy, it's notebook driven, and there's a lot of R code, which is not necessarily famous for its readability. Yeah, it's critical. So we follow quite stringent coding patterns. That doesn't really mean that we have a strong opinion about trailing commas or leading commas in SQL or something like that, but it means that we want to make sure that code is readable, that it is self-documenting in a way, that there's clear documentation available as well, and that because of the peer review, right, you are forced to make sure that it's a core part of your delivery. Because yeah, you want to collaborate. If we require you to collaborate, I think it's the way every data team should be run. Infrastructure as code means that that level of coding standard is true across the board. So not just for your data loading or data model, but also for your visualization and your reporting. And if you run data analysis, I think this is a good example of where some of the newfangled tools are falling down a little bit, because yeah, you got great notebook tools, but a lot of them don't really have proper version control. And when they have version control, it's very UI-driven version control rather than Git-driven version control. Give me Git every day of the week, because it allows me to force the team to use coding standards and be sort of reprimanded for it if they don't. So yes, in short, very important. It's the way to collaborate. But scientific code, I mean, it depends on the data science you do. If you do a driver analysis, that's just a one-off ad hoc thing. I do expect you to sort of document the inputs and your way of thinking, but that's more of a narrative than it is code, right? On the other hand, if it is a segmentation that you're supposed to be doing every single day, well, that very quickly gets into production code, and therefore. Right. Come to my talk tomorrow. We'll talk about that. So data cleaning and so on and so on. Yeah, there's standards there. So I'll be talking tomorrow morning about the exact standards we use in sourcing and staging tables, for instance, with some examples there as well. But yeah, there's code patterns we want you to use. DBT macros is very powerful for that, by the way. So being able to centralize your functions that you develop, for instance, for deduplicating 5-trend data. Those are patterns that we want to write once, maintain centrally, and then deploy everywhere and use everywhere as well. Yeah. Steph. Thank you. Mm-hmm. Yeah. I didn't catch the last part, sorry. Mm-hmm. Yeah. Yeah. So when you build a tracking plan, it's at that point that, and this is subjective, that we do the design of the data model as well. Right? Because, for instance, if you imagine that part of your domain model is a user, right? You define a user object. You know, a user object has, for instance, a required user ID and a required registration timestamp. That could be the design considerations around defining user object. That registration timestamp needs to come from somewhere. So at that point, you then say, well, actually, is there a tier 1 event we can bring into the tracking plan that allows us to fire a registration event to RudderStack, for instance, that gives me the registration timestamp straight away and all the context around where that event happened and for what user fingerprint it happened and so on and so on. So there the tracking plan actually goes hand in hand with the domain model. The two need to coexist, Steph. So being able to do that properly, using your central event governance tool, making sure that if you have your domain model, that you have straight links to your tier 1 and tier 2 events. Yeah, that's the way to do it there. We can talk about some examples tomorrow there, but for instance, the registration of a user is one of the examples. You define the fact that a user needs to be registered, that's the entity, and that the entity has an event associated with it, and you translate that back into your tracking plan. Yes? Yeah. Yeah. This is why our day rates are so high. That's all. No, it's so if you have different departments that don't agree on, for instance, the definition of a user, or actually, as it happened for a couple of our clients, the definition of a lead, because marketing thought about a lead as anyone that came into HubSpot, for instance, whereas sales was like, no, actually, we have to qualify the lead first before we can properly call it a lead. Making them aware of the problem is step 1. You can force it. You can just build it as a qualified lead, for instance, and take the stringent definition. But it will typically cause some political problems, and particularly if you're an outsider, that's not really that relevant. If you're an internal data team, do not underestimate your position of leverage you have. You can get people around the table, and you can tell them, people around the table, you need to align on this definition of a lead because I can't build a dashboard otherwise. We need to get it done properly. In this particular case, we solved it by just saying, okay, well, there's a sales qualified lead and there's a marketing qualified lead. So there we go. So, yeah. All right. Any last questions? Yes. Yes. Yeah. 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 So how much time should you spend on documentation? Balance between code as documentation versus actually spending the time to write it all down. Probably more time than you think to be spent on documentation, right? But I think it depends on the use case. So if you build the core layer of your data warehouse domain model, that needs to be very well documented, and the domain layer code itself is self-documentable in a way as well. And you're helped by the DBT features around reporting and so on, that around documentation that you can build on top of that. But we spent a lot of time documenting that because we know that layer is going to be used as long as the data model is in use. So forever, hopefully. If you're just building a quick presentational data mart in order to very quickly get a report for marketing out the door, documentation is less important. We still require you to build it because it needs to be peer-reviewed by one of your peers. And in order to do that, you need to explain what it is that it does. And the simple sort of rule we try to use is that if you find yourself having to explain to your colleague what it is that you actually try to do, if the code is not self-explanatory with the documentation that you wrote around it, then you probably haven't documented it well enough. It needs to be understandable by your peers. But for the core infrastructure parts, that's where the documentation needs to be really strong. So probably spend 50% of our time on making sure it's there. Yeah. Because the domain model, again, the value of it is not even necessarily in the code, it's in the design, and that means it needs to be documented. Same with the tracking plan, by the way. Yes. Sorry, I thought you... No, that's right. You just raised your hand out of agreement with my statement. That's fantastic. All right, everybody. Thank you again for joining this. You made the right choice. Hopefully you go now and be that 15% of data teams that are successful. So thank you.